week, we are only going to be doing one section, chapter 7.7, and we'll be taking a quiz as well. The quiz will be on chapters 7.5 through 7.7. It has to do with factoring. But it's not a real quiz. You have as many chances as you want, and you can get help if you want. You just need to get 80%. Once you get 80% on that quiz, and you have 80% on the assignments from 7.5, 7.6, and 7.7, you'll get a P in Power School for the standard on factoring. Today, we are going to really continue our factoring, but we're going to think back to chapter 7.3. In chapter 7.3, you learned about a special pattern called a difference of squares. And today, we're going to learn to factor a difference of squares. It's very, very easy. This is an easier section than last week, so you can just relax and be like, good. This is a difference of squares, this right here, this x squared minus 25, because, well, it's a difference because there's a minus, and it's a difference of squares because each of these terms, the x squared and the 25, they are perfect squares. A perfect square is a number that you can get by multiplying something by itself. Like 5 times 5 is 25, so 25 is a perfect squared, and x times x is x squared, so x squared is a perfect square. When you have this pattern, it is very, very easy to factor. Let me just give you a short example of how it will be done. Think of this way. Think of this as x squared plus 0x minus 25. There's like a 0x in there. Could you think of two numbers that multiply out to negative 25 and add up to 0? Multiply to negative 25 and add up to 0. Well, I can. It's pretty simple, isn't it? The two numbers that multiply out to negative 25 and add up to 0 happen to be 5 and negative 5. And therefore, this is the factored form. You're done. We should check it to make sure we're doing it right. So foiling, x times x is x squared. Then we'll go x times negative 5, negative 5x. 5 times x is positive 5x. And then 5 times negative 5 is negative 25. These terms cross out, and you're left with x squared minus 25. If you feel like you've seen this before, it's because you kind of have, except that we were going backwards in chapter 7.3. We were starting here and getting this. Today, we're starting with this, and we're ending there. Okay, so what I'm going to have you do now is I'm going to have you try one of these on your own, even though we've only done one example, but it's pretty easy. So here we go. Let's try example 2, and I'll have you pause it in just a second. So I want you to factor x squared minus 49. Pause the video, you do it. I hope you got this. I hope you got x minus 7 times x plus 7. Now, it doesn't matter which one's minus, which one's plus. It could have been x plus 7 and then x minus 7. It won't make any difference because when you multiply right here, you just get x squared. This gives you the positive 7x. This gives you the negative 7x. And this gives you the negative 49. These, of course, cross out. And therefore, this is the answer that you're going to want to put into your assignment today. That is the factored form of this difference of squares. Let's do one that's a little more complicated, but again, I don't think you're going to find this hard at all. Let's do it without numbers. What about x squared minus y squared? That's a difference of squares. There's a minus, that's a perfect square, and that's a perfect square. I bet you could figure it out even without me telling you, but I'll tell you. All right, what times what gives us x squared? Yep, x times x. What times what gives you y squared? Yep, y times y. So let's make one of these plus and one of these minus, and let's see what happens when we multiply. X times x is x squared. X times negative y is negative xy. Y times x is positive xy. And y times negative y is negative y squared. These two cross out, and you're left with x squared minus y squared. That's it. By the way, when I wrote xy, I could have written it also as yx. It doesn't make any difference. That's the same thing. So now I'm going to give you a fourth example, and I want to see if you can do it, but I'm going to throw a little curveball in your direction. But I bet that if you pause the video and think about it, you could figure out how to do this one. Try it. Pause the video and give it a go. Did you think of this? What times itself gives you 4a squared? Well, that would be 2a times 2a. And what times itself gives you negative 25? Well, that would be 5 and negative 5. So let's see if it worked. So this times this, that gives me the 4a squared. This times this gives me negative 10a. This times this is positive 10a. And this times this is negative 25. These cross out. So we know that this has to be your answer. Let's do one last example. And in this one, most truly, I'm going to make this one hard. We're going to go 196p squared minus 1. Pause the video and think about it. Then see if you get what I get. You should have had this. Well, what times itself gives you 196p squared? Well, that would be 14p times 14p. And what times what gives you 1? Oh, that'd be 1 and 1, but it needs to be negative 1, so 1's positive and 1's negative. And there's your answer. I'm not going to check this one, but you know the pattern. You could check it and it would work. Okay, so that is the first of the patterns. It's called factoring a difference of squares. It's very easy to do. I think you're going to be fine with that. The second and last pattern for today. Uh-oh, what did I do wrong? Whoa, undo. Don't do that. Move up. Thank you. The second and last pattern of the day is going to be a pattern called factoring a perfect square trinomial. I hope you're taking notes with me. By taking the notes, you learn. This isn't like a movie that you can just watch it. You actually need to participate here. Factoring a perfect square trinomial. Okay. So as you can tell with this one, obviously we're going to be factoring a trinomial. And this trinomial is going to be a perfect square trinomial. I'm really having a hard time here. Sorry about this, guys. Come on. All right, here we go. Example 1. We are going to factor x squared plus 6x plus 9. First of all, you should all agree with me that that is a trinomial. That's a second degree or quadratic trinomial. Secondly, it's a perfect square. Remember that a perfect square is a number like 25, which can be found by taking some other number and squaring it. 36 is also a perfect square because 36 is 6 squared. This is a perfect square trinomial because it too can be written as something squared. So we're going to, when we factor it, whatever's in this parentheses and whatever's in that parentheses are going to be the same. So it's going to end up being whatever's in here squared. So watch. Let's see. Oops, put that back. Can you think of a number that, two numbers, excuse me, that multiply out to 9 and add up to 6? Two numbers that multiply out to 9 but add up to 6. Well, 3 and 3, isn't it? So x plus 3 and x plus 3 will be my factorization. We could check it, of course, by foiling, and you would get x squared plus 6x plus 9. I will do it once just for good measure. So there's your x squared. There's your 3x. There's your other 3x. And there's your 9. Notice that these two middle guys are like terms. They don't cross each other out, but they get added together this time. And you get x squared plus 6x plus 9. However, because x plus 3 and x plus 3, they're the same binomial, another shorter way of writing x plus 3 times x plus 3 can simply be x plus 3 squared. So in your assignment for this one, you're just going to want to write that, x plus 3 in parentheses squared. Pretty easy, huh? Let's do another example. And for this one, I'm going to write it down and then ask you to pause the video. And oops, I forgot the x. Pause the video and see if you can do it yourself. All right. Write it down and pause the video. I hope you did this. I hope you wrote it as x plus 5 times x plus 5, or very simply, x plus 5 squared. If you did that, you get it. You're doing it right. Let's do one that's a little more difficult, and we'll call this one example 3. And let's put a negative in there. So I'm going to use a y. So y squared minus 12y plus 36. This one also is a perfect square trinomial. And, oh, I bet you can do it. Pause the video, do it yourself. All right, I'm looking for two numbers that multiply out to positive 36, but at the same time add up to negative 12. So that's going to be y minus 6 and y minus 6, or simply y minus 6 squared. All right, we're going to do two last examples, and now I'm really going to step it up. So in your book, you're going to see one that looks like this. All right, now you're scared. Oh no, there's a 9 there. Yeah, that's kind of an oh no, but not really. All right, is this a perfect square? Is there something that multiplied by itself gives you 9y squared? Yes, there is. Think about it. 3y times 3y equals 9y squared. For those of you geniuses out there, we could say it this way. The square root of 9y squared equals 3y. Is there something that multiplied by itself gives you 4? Well, of course there is. So let's go ahead and do it this way. So this times this needs to give me the 9y squared, but those two terms must be the same. So that's going to be 3y times 3y. This times this needs to give me 4. And the terms need to be the same. So it's going to be 2 and 2. However, there's a negative there. So I can't have plus and plus because I would never get a negative anywhere with that. So it must be that these are negative. Let's see if it worked. So this times this certainly gives me the, well, I'll put it down here, gives me 9y squared. This times this gives me negative 6y. Now the insides, negative 6y. And now the last. And as you can see, these two guys add up to negative 12y. So I know this is correct. However, in the assignment today, I'm going to write it like that. Let's do one last example. And once again, for this one, I'm just going to have you do it yourself. Because if you can do this, you can do the assignment. So if you take good notes, you're going to be fine. All right, 4x squared minus 4x plus 1. Pause the video and give it a go. I hope you did this. To get 4x squared, you need to multiply 2x times 2x. To get 1, you got to multiply 1 times 1. To get this middle term, since it's negative, I'm probably going to have to use some negatives. Let's check it now. The f of FOIL, the first times the first gives me that. Now the outsides, now the insides, and now the last. These two are like terms which add up to the negative 4x, and therefore your final answer is 2x minus 1 squared. That's it. The hardest section in chapter 7 is 7.6, where you had to do that guess and check. However, I think most of it's pretty simple. If we were in class, we'd be doing a lot more with factoring, but for this year, we're going to stop right there. I just need you to be familiar with it. So 2 assignments, one on 7.7, and then a quiz this week. Good luck, and if you have questions, please ask. I'm here.